So far, we have learned about solving system of equations by graphing and by substitution. And now we're going to move on to the third approach, which is called elimination. And this one's one of my favorites. So let's go ahead and start with the elimination method. There's our little roadmap of where we are. We've started with graphing, substitution, and now we're on to elimination. And you might wonder, when is it appropriate to use the elimination method? Well, that's going to be easy. It's when both equations are in standard form. And you might have forgotten what standard form is, and I'll explain that in a second. But when both equations are in standard form, then it's going to be easiest to use the elimination method. So you might have seen with substitution, we use substitution whenever we see x equals something or y equals something, and then we just substituted it. We're going to use elimination when you see this form, ax plus by equals c. It's when all of the x's and all of the y's are on one side, and you just have a number on the other side. That's called standard form for a linear function. So let's take a look. Which of the following equations would be best solved with the elimination method? We're going to circle all the ones that you would use elimination for. So for the first one, the top one, yep, that's good. It's in standard form, so we could use it. However, the bottom one, that's not in standard form. So we would not use the elimination method. That's one that we would approach with substitution. The second one, I see the x and I see the y all on the left side, and then it equals a number. So both of them are in standard form. So yes, we could use the elimination method for this one. On this one, it basically is standard form. It's just kind of flipped around, but that's fine. All of the x's and y's are on one side, and then just a number on the other side. So yes, both of those are standard form, and we could use elimination. And for the next one, you see y equals. This would be a substitution problem. They're both in slope-intercept form. We'd use substitution for that. Just to start to get the hang of it, we're going to do a couple examples. I'm just going to give you a warning. They will not always be this easy. I'm just trying to show you the concept of what's going on with this problem. So don't get too comfortable. It won't always be this easy, but this is just to show you the concept. Hopefully what you notice here is when you look down at this 4y and this minus 4y, well, they're going to cancel each other out. This is why it's called the elimination method. When you think of the word eliminate, you think of like going away, disappearing, and that's what we're going to do to a variable. When you see this 4y and minus 4y, the same number, but opposite signs, they're primed to be eliminated. So these are already set up to be eliminated. And all you have to do is just add the two rows together. So let's see what happens when we do that. We're just going to add the two rows together. If I take 3x plus 2x, it equals 5x. If I add 4y minus 4y, it becomes nothing. That's why it's eliminated. And then if I take 96 and negative 36 and I add those together, we get 60. So all of a sudden, by adding the two rows together, the y's have been eliminated. Now, it won't always be that easy, but for now you can see that the y's are gone. Then to solve for x, we can divide by 5. And when we do that, we get x is equal to 12. So we've solved, and we've found that x equals 12. As you know, we still have to solve for y. So you can choose either the top one or the bottom one to plug it into. I'm going to choose the top one. So I'll start with 3x plus 4y equals 96. So I'm just starting with the copy of the first equation. And I know that x is equal to 12, so wherever I see an x, I'm going to replace it with a 12. So we're going to do 3 times 12 plus 4y equals 96. 3 times 12, you can simplify that to equal 36 plus 4y equals 96. And once you get to here, hopefully you're pretty comfortable with this. We get rid of the 36 by subtracting it. It goes away. we're left with 4y equals 60. And then to solve for y, simply divide by 4. And we get y equals 15. So let's go back. We found that x equals 12. We found that y equals 15. Remember, you have to write your answer as a coordinate point. So our answer would be 12, 15. And that is how you approach the elimination method. And this is what you have to see in order to eliminate it. One of them being positive, one of them being negative, with the exact same number in front. So 4y and negative 4y, they canceled each other out. Let's do one more together. On this one, you will notice that the x's are now going to be eliminated. If I add these two rows together, then 2x and minus 2x, it becomes 0x. It's gone. So the x's are eliminated. And we're going to have y plus 3y equals 4y. And if I take 1 plus 27, we get 28. To solve for y, divide by 4, divide by 4, and we've found now that y is equal to 7. I know the value of y is equal to 7. Now let's go ahead and solve for x. You can choose the top one, you can choose the bottom one, it doesn't matter. I think this top one looks a lot easier. Let's use the top one. So we're going to start with 2x plus y is equal to 1. And since we know that the value of y is 7, I'm going to replace this y up here with a 7. So the y turns into a 7. And now it's just solving like normal. We're going to get rid of the 7 by subtracting it. So we get 2x equals negative 6. Divide by 2 on both sides. And we get x is equal to negative 3. Don't forget, write your answer as a coordinate. Negative 3 and 7 are going to be your coordinates. And there's your solution. So hopefully this elimination method kind of makes sense for now. It will get a little bit more difficult, but just to make sure you understand the basics of it, try these two on your own. When you are done, you are going to submit them to Schoology. So go ahead and hit pause on the video. And when you are all finished and you're comfortable with it, come on back and we will do it where it's one more step more difficult. So go ahead and hit pause and come on back. All right, hopefully those were simple enough. We're going to move on where we now have to manipulate one or both of the equations to get them to line up. So for this first example, we're going to solve the following system of equations with the elimination method by eliminating the x first. You can choose to get rid of x, you can choose to get rid of y. It really doesn't matter. You'll get the exact same answer. But for this one, I'm going to be eliminating the x first. And you'll notice, if I look at this 3x, I don't have the matching negative 3x that will cancel it out. Remember, if you see 3x and negative 3x, this would be great because they then just cancel out. However, all I see is 3x and x. They don't cancel. If I add them together, it equals 4x. I don't want that. So what I'm going to do is I'm going to multiply the bottom row by a negative 3. So I'm going to put a little negative 3 here in parentheses, and it's going to be distributed to that entire row. And let's see what happens when we do that. I'm going to rewrite the top one. So we have 3x plus 2y equals negative 8. And now I distribute the negative 3. So negative 3 times x is negative 3x. Negative 3 times a positive 4y becomes negative 12y. And a negative 3 times positive 14, well, that's a negative 42. And by doing that, hopefully you see why we did that. It's because now when you add the two rows together, what happens to 3x and negative 3x? When I add them together, they're gone. They disappear. They are eliminated. That's why it's called the elimination method. So we want to make one of them a 3x, then the other one's a negative 3x, and they'll cancel out. So then we have 2y and negative 12y. We can add those together, and it becomes negative 10y. And if you add negative 8 and negative 42, it becomes a negative 50. And then we're just going to divide by negative 10, which gives us y equals a positive 5. A negative 50 divided by negative 10 makes it a positive 5. Then we have to solve for x. And again, you can choose the top one up here. You can choose the bottom one here. It doesn't matter. You're going to get the exact same answer. You're probably going to want to do the bottom one, but hey, it doesn't really matter. We'll use the bottom one. So we have x plus 4y is equal to 14. We've found that the value of a y is a 5, so I'm going to replace the y with a 5. So we have x plus 4 times 5 equals 14. We can simplify. 4 times 5 becomes 20. So x plus 20 equals 14. And then to get rid of the x, we have to subtract out the 20. And we get x equals negative 6. So our final answer in this case would be negative 6, 5. So hopefully that made sense. Go ahead and try the next one on your own. Again, I want you to eliminate the x coordinate first. So I'll give you a little hint before you get started on your own. On this one, you see that this is a 4x. To cancel out a 4x, this one would have to be a negative 4x. So you're going to want to multiply the top row by negative 4. So go ahead and pause the video, and when you're all done, come on back for the next example. All right, on to the last example of the video. We are going to solve the following system of equations using the elimination method, but this time we are going to eliminate the y first. Last time we did x, this time we'll do y. So if I look at my y variables, I have a negative y and a 5y. If I add those together, it becomes 4y. That doesn't cancel anything. So if I have this one as a 5y, that one has a 5y, to cancel it out, the top one needs to be negative 5y. Because if I have this will end up canceling out and eliminating. The problem is I don't have that. But what I can do is I can multiply the top row by 5. So I'm going to multiply by 5 on the top row. And we're going to distribute that 5 to the entire row. So 5 times 2x gives us 10x. 5 times negative y is negative 5y. And then 5 times 28 is 140. Then what we're going to do is we are going to just copy down this bottom row. So they all line up. And now hopefully you see why we did that. Because now the negative 5y and the plus 5y, they eliminate. If you add them together, it becomes 0y and they're gone. Once we've done that, that's the hardest part. We just add the rows together. So 10x plus 3x is 13x. 140 plus 29 is 169. And then we can just divide by 13. And that leaves us with x is equal to 13. To solve for y, you can pick the top one, you can pick the bottom one. It doesn't matter. I'm going to pick the bottom one. So we have 3x plus 5y equals 29. Just rewriting it. We know that the value of x is 13. So we have 3 times 13 plus 5y equals 29. We can simplify the 3 times 13. That's going to be 39 plus 5y equals 29. We're going to subtract 39 from both sides. Hopefully you're getting good at this step. And then finally divide by 5. And we end up with y equals negative 2. So your final answer, again, you write it as a coordinate, would be 13, negative 2. And that's the elimination method. Your password, in order to submit these onto Schoology, your password is going to be confidence. I'm going to put a lowercase c. Confidence. CONFIDENCE. F-I-D-E-N-C-E, confidence. Thanks for watching, and enjoy the next video on elimination.